so we've already discussed this, that an acute angle is an angle that's less than 90, and an obtuse angle is between 90 and we said that supplementary angles are two angles that sum to 180. Okay. Now, here's the important part. The Cartesian plane. We're used to the Cartesian plane. It's not something new. It's x and y, right? We're used to them. Now, the difference here, the points are the same. So you have positive values, right? Positive x values, negative x values, right? Positive y and negative y. Okay? It's not changing. Now, there's names for these quadrants, and the names are the following. We start from this quadrant and we go quadrant 1, and then we move counterclockwise, and that will be quadrant 2, quadrant 3, and quadrant 4. Okay? Anti-clockwise, yeah. Counterclockwise. Yeah. So, in this class, in MAP4C, we only deal with quadrant 1 and 2. Alright? So, the angles go like this. We measure always the angle from the x-axis. Okay? And we measure them counterclockwise. Alright? So the angle right here is going to be 0 degrees. Okay? And then as we go up, the degree will go up. So let's say this is 40 degrees. Okay? And then we measure it from the x-axis to the, we call this the terminal arm. Okay? And so this is called terminal arm. Okay? So we always measure from the x-axis. So what would be the angle right here? None. Right? Because that's a right angle right there. Okay? Any angle in this quadrant is going to be greater than 90. Okay? What would be the angle right here? 180. Okay? Because it's a whole line. Okay? It makes a straight line, that means it's 180. Alright? So, we know that the angles in this quadrant are between this is between 0 and 90, and in this quadrant, which is quadrant 2, is between 90 and 1. Right? So the quadrant 1 will be acute angles, quadrant 2 will be obtuse angles. Okay? Good. So, if I'm looking for the ratios of the angles in the first quadrant, what would they be? Would they be positive, negative?
Positive.
All of them. Right? Sine, cosine, and tan are positive. How about in the second quadrant?
The sine will be positive, the cosine and tan will be negative.
That's right. Okay? So, in the first quadrant, sine, cosine, and tan are positive. In the second quadrant, sine is positive, cosine is negative, tan is negative. Are we okay with this so far? Excellent. Okay. Can I move up? So we have used we've used like SOHCAHTOA, right? So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent, right? Now we're going to use the same ratios, but we're going to use x, y, and r instead of opposite, adjacent, and hypotenuse. Because we're going to relate it to the Cartesian plane. Okay? So let's look at this. trigonometric ratio of any triangle can be defined using a point P which has x and y on a coordinate grid. If point P, x, y is in quadrant 1, then angle A is an acute angle, which is between 0 and 90, using SOHCAHTOA to define each trig ratio. So they're telling me that point P is in the first quadrant, okay? So I'm just gonna put it right here, okay, just to look at that example. Right? Remember that we always use the x-axis to measure my angle, right? So if I'm gonna form a triangle, it has to go from the origin all the way to the point, and then I'm gonna drop a line to the x-axis. Okay? So do you see a triangle here?
Right.
Do you see a triangle?
Right.
Okay. It's a right angle triangle. Right? Where's my angle of interest?
That's from 0? No. It's the point that you draw from.
It's this.
Yep.
This is my angle of interest right here. It's between the x-axis and the terminal arc. Okay? So that's my angle of interest. Okay? Now, if I'm looking at this right here, this is x, correct? So this right here is x. So if the value of the point is 2, then this is going to be 2. You guys agree with me? Okay? The value of the y is 5. The value of the y is 5. Then this is going to be 5. So that's y, right? So in the triangle, this is x, this is y. Are we okay with that so far? Okay? Okay, so I'm just gonna do a quick sketch here. So if I say the point is 2, 5, again, okay? So this is 2, this is 5, so this is my point, right? I'm gonna form a triangle, right? Angle of interest is from the x to the line, to the terminal arm, right? And this is my y value because that's my y, right? And this is my x. Do you see that? X is on the horizontal, y on the vertical. How many of you understand that? Joan? Yeah? Okay. Now, the longest side, which is technically the hypotenuse, right? It's this.
Yeah.
Right? We're going to call it R. The reason why they call it R is actually if they do draw a circle, right, where the origin is the thing, that's going to be at the radius of the circle. Okay, they call it R. But it's the same thing as the hypotenuse. Okay? Now the question is, I know x, right? Because it's on the coordinates, it's on the point. I know y because I know my point, right? But I don't know my r. How can I find r?
So we use a hypo or like
Do we use SOHCAHTOA? Solution? No.
It's
we are not
hypo.
using sign on because I'm really
No, it's hypo, and then that's why we have to add x and
You add x and y, but what's the formula? It's not just add x and y.
Is it standard form?
C squared. No, C squared equal A squared plus B squared.
Oh, okay.
What's that
Right?
now?
This is the Pythagorean theorem.
Oh, sorry.
Right? This right here is your hypotenuse, so that's your C, right? So this r squared equals to x squared plus y squared, right? Using, if you want, using the Pythagorean theorem, but I changed the letters, right? And then instead of C I have r, instead of A I have x, instead of B I have y. Right? So technically r is the square root of x squared plus y squared. Okay? So if you know x and y, if you know your point, x and y, you can find the radius, or r. which is the hypotenuse. Okay? Now, this is your angle of interest, right? We defined it before. If you are looking for sine of that angle, what would it be in terms of x, y, and r?
Oh. Mean the angle?
Opposite over hypo. What's my opposite?
Opposite is x.
Y. And what's my hypotenuse? No, R. Okay? So if you're looking at this, this is your opposite, right? Which is y. This is the opposite of that angle. And this is the hypotenuse. This is the hypotenuse, right? So it's going to be y over r. Okay? Now, what would cosine be with respect to adjacent over hypo?
Adjacent over height.
X over
Adjacent over x over r.
Okay? Adjacent is this. And the hypotenuse is this. So it's x over r. Now, what would tan be?
And will be over
Which is what?
y over x.
Opposite over adjacent. So y over x. So if you know your point, and if you know the coordinate of your point, you can find sine, cosine, and tan of that angle that forms with the x-axis. Okay? All right. Oh, you want me to go back? I'm just gonna save it while we're videoing here, just because. Sorry guys, just one moment, okay? I don't want to lose everything I wrote. You guys still need this?
Yes.